You've set up your first project and now you're keen to add autograding. Well, you're in luck. Let's get started. Now I'm keen to have 3 tests, 3 grades within my program. And I'm going to go to the unit testing option. And I've got 2 kinds of unit tests that I can add in. Unit tests themselves are language-specific, programmatic ways of testing code. You can use these if you want, and you may need to use these if you've got some extreme cases. However, for most needs, the input and output tests are by far the best way to run it. These are slightly simplified tests that allow you to get your autograding in quicker and with much less fuss. I'm going to create a test, and the first test I'm going to create is for the area of a rectangle. So I'm going to give it the name. In the input box, I'm going to type in the inputs that the computer is expecting in order. And that will be this. So the first time an input prompt comes up, the computer is going to enter rectangle. The second time, it's going to enter 5.0. The third time, 10.0. Point zeros are important because in my question, I've specifically asked for floating point numbers or decimal numbers to be used. If you're not using those, you don't need the point zero. Expected output. I'd expect to see this answer. Now you may have used this sort of system in the past on other websites and been frustrated by it, because normally what this sort of system does is it looks for the exact output, spaces, capitalization and all, and a student could lose marks by not having things in quite the right order. Well, there are a bunch of options in our unit testing that makes that a little bit easier. Match and exact are the ones that look for the actual output itself. Regex will allow us to write a regular expression to identify whether the output is exactly as we think it is, and this is really handy if you're doing things like random seeding. For instance, a rock, paper, scissors game, you could use this to match up the computer's random choice to what the output should be. But for most cases, compatibility is what you want. Compatibility is going to look to see if this output exists in the output at all. So a student could surround this with some nonsense, a bunch of emoji, too many spaces, or some ASCII art. They could even misspell the entire sentence either side of it, and they would still get the marks as long as the program computed the correct output. I'm going to add in a test now for triangles. And this works in exactly the same way. I'm going to put in the inputs that I would have expected and the output. I'm going to set this also to compatibility mode. One more test, this time for an error case. Now I've said in my instructions that if anything else is put in, the computer should output the word error. I'm going to pop that down there and set it to compatibility mode. Now when my computer tries to add the data for a decagon, we should see an error message and the computer should mark it correctly. Now I can't quite test those at the moment because I've only got boilerplate code. But we'll have a look at how that works in a student piece of work in a moment. But what I can do now is go and write a solution, a correct solution, which might be visible for other teachers, or it might be something you want to give the learners. Either way, that should be your next step. Now I could simply publish it as it is, but I'm not going to do that because in the next video, we're going to look at creating the worked solution to this question.